Okay, let us discuss the short notes on mass sensing element and the thermal detector in the today's class. So what do you mean by mass sensing element? Mass sensing element is an inertia and accelerometer. The inertia of a concentrated mass is a fundamental mechanical detector transducer element. So application is it is used in the accelerometer, and the function of the mass sensing element is measures the dynamic motion characteristics such as displacement, velocity, acceleration and a frequency by applying a Newton's law of motion. So this is a short note on the mass sensing element. So we have different categories here again: inertia of accelerometer, pendulum and time frequency transducer. So pendulum as a time frequency transducer. Here the pendulum or any simple mechanical vibrating member serves as a time or frequency transducer. The function is it divides the passage of time into a discrete intervals and useful for timekeeping and frequency measurement. So next is manometer for pressure measurement. It works with the principle of mass displacement and it is used to measure a pressure, and it can also be viewed as a elastic device where deflection is proportional to the applied force indicating pressure. So in the mass sensing element, when they ask you to write a short note on mass sensing element, you are supposed to write the three different division here: inertia and accelerometer, pendulum as a time frequency transducer, and manometer for pressure measurement. You need to write at least three lines on each of it. So here, as I had said you, that concept, function and application is being explained here. So next is a thermal detector. So thermal detector are a device used to measure a temperature of solid, liquid and gas. These sense a temperature changes by utilizing one of the following primary effects: change in physical state, altered physical dimension, and change in electrical properties and change in radiating ability. Mean by thermal detector, it is nothing but it is sensing the temperature. So here the thermal detector, which senses a temperature. How do it senses? It senses by utilizing it will look into the changes in the physical state. Next, coming into the changes: physical state, chemical change, altered physical dimension. By all these things, we will sense the temperature. Okay, the best example, the most commonly used thermal detector are the glass thermometer. Okay, the most commonly used thermal detector are glass thermometer, mercury filled, mercury nitrogen filled or alcohol filled, pressure gauge thermometer, vapor filled, liquid filled and gas filled, bimetallic thermometers, thermocouples, resistance thermometer, thermistor, pyrometers. In the pyrometers you have three different types, that is optical, radiation and a fusion. Most popular thermal detector used are thermocouple and a resistance thermometer. Thermocouple, it measures the temperature based on voltage generated at the junction of two different metals. Application widely used due to their wide temperature range and fast response. A resistance thermometer measures the temperature based on the change in electrical resistance of material. So here the thermocouple means a measured temperature based on the voltage generated at the function of two different metals, widely used due to their wide temperature range and a fast response time. Resistance thermometer, here the function is measured temperature based on the change in electrical resistance of a material and known for their accuracy and stability over a wide temperature range. These are the short notes on the thermal detector. So you will write the different applications of thermal detector and how it actually detects. So next question is, the list the sensors of motion and explain the linear motion potentiometer and linear motion variable. So first is linear motion. There are different types of sensor. First you need to know what do you mean by sensors of motion. You need to know what do you mean by sensor. What do you mean by sensor? Sensor, you can see widely where it is being used. It is used in mall to open the door automatically. It is used in lift. It is used in many applications. So first you need to know what do you mean by sensor, and then we will look into the different types of sensor and the sensors, different types of sensors of motion. You have a light sensor, temperature sensor, and many different kinds of sensors. Many industrial process requires a sensor to detect the linear motion of moving component, and these sensors. So here the various types of sensor for detecting a linear motion include linear motion potentiometer, linear motion variable inductor, linear motion variable capacitor, linear variable differential transformer. So here look at the diagram of the linear motion. First we shall discuss about the two types of um, sensors, that is linear motion potentiometer and a linear motion inductor. So in the linear motion potentiometer you can see the diagram of it. So here you have a slider, arm and component whose linear movement is to be detected, housing, resistance element connected to a measurement or a control unit. So here you have a slider. So name itself says it is a linear motion potentiometer. So it works like you need to vary some resistance here. We use a slider to move it so that the resistance element is being changed. So it just acts like a variable resistance box. When we change a knob, the resistance will vary. The same way when we slide a slider, here the resistance will vary. So hence the name linear motion potentiometer. So when you are writing a diagram, make sure you will write the diagram properly with the naming of all the components here. So coming into the next thing is how it actually works. Here the as I had said you, the device uses an arm connected to a soft iron core which moves into and out of the coil, changing the coil inductance. So here the mechanism is the linear movement of the arm moves the soft iron core within the coil. The inductance of the coil increases as the core moves further into it and decreases as the core moves out. The direction of motion is indicated by whether the inductance is the function is the device is a variable resistor with its resistance varied by the moment of slider over its resistance element. The slider is connected to an arm moved by a component whose linear motion is to be sensed. As the slider moves, it shorts out the portion of the resistance varying the potentiometer resistance. The movement to the right increases resistance while movement to the left decreases it. The direction of movement is indicated by whether the resistance is increasing or decreasing. When the component is stationary, the resistance remains constant. Resistance can be measured by Wheatstone bridge circuit. So here overall the summary is the resistance is varied in the linear potentiometer. This is a thing which you need to know. So we are varying a slider by using an arm where the resistance will be varied, and this is measured using a Wheatstone bridge network. Next is a linear motion variable inductor. So in this the device uses an arm. You can see the diagram here. Again in the diagram you have an arm, you have a soft iron core, you have a coil, you have a housing and connected to a measurement or a control circuit. So here The device uses an arm connected to a soft iron core which moves into and out of the coil and changes the coil inductance. So the mechanism is linear movement of arm moves the soft iron core within the coil. The inductance of coil when it is moved inside, the inductance of coil increases as the core moves further into it. When it is taken out of it, the inductance of the coil will decrease. This is the overall working of it. So you need to understand this is sent inside. This is due to the magnetic field which is generated over there, and when it is taken out, the inductance will be decreased. So here the direction of motion is indicated by whether the inductance is increasing or decreasing. The changes in inductance is proportional to the linear movement of the core. The sensors helps in converting the mechanical motion into a electrical signal, facilitating the precise monitoring and control in industrial application.